next comes the function. So functions are built-in commands that are used for performing different mathematical and other such operations. So some basic functions are being presented in this slide. We'll be testing them in the Matlab environment also. So the square root function written is like this in the Matlab, sqrt, and then in the parentheses you'd provide the value that you want to take the square root of. So for example, if you write the square root of 16, it will give you the square root of this number 16, which is 4. The next one is the nth root. So the nth root takes the nth root of a number. So suppose that if you take the 7th root of 49, you'd get the result accordingly. Next one is the exponential function. So it takes a value and make it in the power of the exponent e, which is a predefined constant. Another one is the power operator, which we saw earlier also. So let's try these three functions and see what the result look like. So I'll again clear these and then clear the command window. You can write it here line by line and then execute it, or you can write it in the script and then run it in order to generate the results. But for just the demonstration purposes, I'd mostly stick with the command window because it instantly generates the results, and we see the results instantly, so that's why. So let's take the square root of simple number 16. So if I write square root of 16 and hit enter, I'd get 4. Now I can assign this answer to a variable called square root, or whatever we want the name to be. We'd be seeing the rules for how to declare the variables and how to name them as we proceed through these slides. But for now, let's just write some random name like square root equals to the square root of, let's say, 64. So here again, if I terminate with a semicolon, then the square root would be assigned to this variable, but it won't be printed. But if I remove this semicolon, then hit enter, now it is executed. The result is assigned to this variable square root, and it is also printed to the command window. So as expected, the square root of the number 64 is 8. Let's take the nth root function and see how it generates the results. So let's declare a variable nth root equals to nth root, which is the name for the function. So remember that these functions are predefined Matlab functions, and they should be named exactly as they are being written within the Matlab. So if you change any of the variable here, or if you suppose remove a single O from here, then it will generate an error because it has to be spelled exactly as they are. Right now you might be wondering that how to know all the functions and all that. So it's not a bit difficult thing. The functions that are for your significance, that are important to you, you can search them on Google also, or you can see it from the slides. And so there are a lot of like help available in order to know the functions, the predefined Matlab functions that are presented. We'd be discussing the documentation in the next slides, how to learn from documentation, or how to search different functions, or how to get help on those functions. But for right now, let's just do the nth root example. So suppose I want to take the third root of the number 8. So we know that the third root of the number 8 is 2, because 2 times 2 times 2 is 8. So if I multiply 2 3 times, I'd get 8, like 2 times 2 times 2 is 8. We know that. So let's check if the MATLAB is able to do that. Now as I hit enter, the result is assigned to this variable nth root. If I want to print what value it is storing, then I can just write the variable name and then hit enter. So as expected, the value 2 is stored in the nth root. You can try different examples and see different numbers and take the different roots of it and see it for yourself also. So the next one was the exponentiation. So the exponentiation function works something like this. So whatever you write inside these parentheses, it will make it rise to the power of the exponential constant, which is 2.7 something. So if you want to know the exact value of that exponential constant, you just rise it to the power of 1. So if I rise it to the power of 1, we know that the power of 1 is nothing but that number itself, which is 2.72. Which is the natural exponentiation constant. You can find the details for this exponential constant on Google also, but I'm expecting that you're aware of this variable already. So if I rise it to the power of 2, I'd get the corresponding result. Some other elementary mathematical functions include the absolute function, the logarithmic functions, the logarithmic function to the base of 10, and the factorial one. So let's check each one of these in action. So clear CLC. I'd better close this script right now and work with the command window directly. So the first one is the absolute value. So suppose I store a variable, a value of -10 in a variable called a. So a has got the value of -10. Now we know that if you take the absolute of any constant or any variable, it will make it positive. It will drop the negative sign. So suppose that I assign to another variable b the absolute value of a variable a. So now b would have exactly the same value as a, but if it's a negative value, then it will make it positive. So that's what the absolute function do. Logarithmic function takes the logarithm of a value. So if I write log of, let's say, 100, then it will take the log of it and will return the result. Now this simple log keyword, when you write it, this is basically to the base of e. So this logarithm is to the base of e. If you want to take the logarithm to the base of 10, then for that the function is log 10. So if I take the log 10 of 100, it will give us 2, because base 10 logarithm 10 raised to the power of 2 gives us 100. So that's why log to the base of 10 of 100 gives us 2. So that's how logarithm works. The factorial function takes the factorial of a number. So we know what a factorial is. So if I take the factorial of 4, so factorial 4 will return us 24, because 4 times 3 times 2 times 1 is 24. So these are some basic MATLAB functions. There are tons of such functions that are useful for different purposes and are used in a lot of the different applications. You can find a lot of them either online or in the documentation section that we would be discussing in the upcoming slides. Some more important functions are the trigonometric functions. So if you want to take the sign of a value, you just have to write sign and then specify the value that you want to take the sign of. But the angle that it takes should be in radians. So the function sine expects this argument x to be in radians. So suppose that if you want to take the sine of, let's say, 90 degrees, then 90 in radians is pi by 2. So writing sine pi by 2 would give you the sine of the angle 90. If you want to take the sine in and you want this argument to be in degrees, then the function for that is sine d. So sine d would take uh, uh, the sine of the argument x that is in degrees. Same goes for the cos and the tangent. So let's check them out in the Matlab environment. So clear CLC again. So one thing more, as we would see in the upcoming slide also, that the Matlab, there are some predefined constants that are stored into the Matlab, and they have been assigned predefined keywords. So if you write those keywords, it will return, the Matlab would return the values for those specific variables. So one of those variables is the variable pi, or the value pi, the constant pi. So if I write pi, it will return me the value for the constant pi. So let's write sine pi by 2, which is sine 90 in degrees, or pi by 2 in radians, and the expected answer is 1, because sine 90 or sine pi by 2 in radians should give us 1. So if I press enter, it returns me 1. Now if I write cos pi by 2, it should give us 0. So cos pi by 2 gives us zeros as expected. Now if I want to take sine of the angle, but that angle is in degrees, then it the function for it is sine d. So sine d of 90 should give us 1 again, and cos d of 90 should give us 0. Same goes for tangent. So tangent of, let's say, pi gives us minus 0, or tangent d of, let's say, 90 gives us infinity. Infinity is another such special variable that is stored into the Matlab and is used for the number infinity. Infinity is not really a number, but the concept, I hope that the concept of infinity is clear to you in advance. So infinity is stored in the Matlab by the variable name inf, or the keyword. It's not really a variable, it's a keyword. So that's that. You can try different such functions, trigonometric functions, and practice with them and see the results for yourself.